Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following cubic function questions. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. We have given f of x equals 2x cubed minus x squared minus 4x plus 3. The first part of the question says, show that x minus 1 is a factor of f of x. To show that f of x minus 1 is a factor of f of x, that is only possible if x minus 1, that's the factor we're trying to show, then we have f of 1 will be equal to 0. I got my f of 1 by equating, we have x minus 1 equals to 0. So we make x subject to the formula, x is equal to 1. So if I plug in 1 as the value of x into my function, and I get the 0, then what that means is x minus 1 will be a factor. So I'm going to show you how to test that. I'm going to say f of 1 is equal to every occurrence of x. I replace it with 1. I'm using the cubic function stated in the question. So I have 2 times 1 all cubed minus 1 squared. I'm going to put that in a bracket. Minus 4 times 1 plus 3. That will give us 1 cube is 1, 1 times 2, 2, minus 1 squared is 1, minus 4 times 1, 4, plus 3. And if you check this out, this is going to give us a 0. So therefore, x minus 1 is a factor of the cubic function f of x equals 2x cubed minus x squared minus 4x plus 3. Let's go to the second part of the question, which says, hence factorize f of x completely. Remember, the first part of the question says we should show that x minus 1 is a factor, and we've been able to prove that. So to factorize, what I'm going to do first is to divide my f of x, that's 2x cubed minus x squared minus 4x plus 3 by the first factor we had, which is x minus 1. I'm going to use my synthetic division. If you need to understand the synthetic division, check in the comment section for links to how to use synthetic division for your cubic functions. So therefore, I'm going to have divided by 1. I'm going to write out the coefficients of my cubic function, which is 2, negative 1, negative 4, and positive 3. So I'm dividing by 1 because if I equate x minus 1 to 0, I'm going to have x equals to 1. So the first step, I'm going to bring down the first coefficient here, which is my 2. And draw my line. So the next step is 1, which is what I'm dividing with, times 2 will give me 2. I write it under the second coefficient. And then I add the 2, negative 1 plus 2 is positive 1. So I repeat the process. It's similar to my long division. 1 times 1 is 1. So I write my 1 here. And then I have negative 4 plus 1. It's negative 3. I repeat the process again. 1 times negative 3. That's negative 3. And if I add that together, that's 0. So having 0 at the end here simply means that I'm able to divide my function by x minus 1 without a remainder. So therefore, if I rewrite my function, f of x will be equal to, I divided by x minus 1, and therefore I'm going to use my new set of coefficient as shown, and then when I'm doing that, I'm going to drop my exponent. So initially I had 2x cubed. Now the first coefficient is 2. That will now be 2x. I'm going to drop my cube to 2, taking out 1, and then I have my plus 1. So my plus 1 becomes plus x, and then negative 3 will be the constant minus 3. X to the power of 0 is 1, so I leave it as that. And then the next step is I need to factorize my second bracket as shown. So therefore, if I'm to factorize completely, my f of x will be the first factor, x minus 1, and then I factorize the other bracket, that will be x minus 1 to x plus 3. So therefore, I've been able to factorize completely my cubic function. Let's go to the third part of the question. To determine the coordinates of the turning point of f, we have at turning point, I'm going to call that TP, my dy dx is equal to 0. So therefore, if my f of x equals to x cubed minus x squared minus 4x plus 3, I'm going to start by differentiating. My dy dx is equal to 6x squared minus 2x minus 4, and we have to equate that to 0. So if I equate that to 0, I'll start by factoring out 2. I'm left with, just to make my work easier, taking out the common factor, I have 3x squared minus x minus 2 equals 0. If I divide both sides by 2, I'm left with 3x squared minus x minus 2 equals 0. So I'm going to factorize my left-hand side. I have that as 3x plus 2. And then second bracket, x minus 1. So therefore, for my first bracket, the value of x will be negative 2 over 3. And for my second bracket, x will be equal to positive 1. So for each value of x, as shown, we need to solve for the corresponding y values in order to get the coordinate of the turning point. So my first step, I'm going to substitute x equals negative 2/3 into my function. So therefore, my f of negative 2 over 3 will be 2 times negative 2 over 3 all cubed minus negative 2 over 3 all squared minus 4 negative 2 over 3 plus 3. And if we substitute for that, my f of negative 2 over 3 is going to give us, for whole number, 17 over 27. So I've done that for x equals negative 2/3. I'm going to do the same for x equals 1. So therefore, I have substitute x equals positive 1. So therefore, my f of 1 will be equal to 2 times 1 cubed minus 1 squared minus 4 times 1 plus 3, and that will give us, therefore, f of 1 will be equal to 0. So therefore, the coordinate of my turning point will be the first one for negative 2 over 3. I have the corresponding y values for 17 over 27. And then for the second point, I have, for my x values, 1. I have a corresponding y value, 0. Let's go to the next part. So therefore, the next question says, draw a neat sketch graph of f indicating the coordinates of the turning point as well as the x-intercept. We've been able to find the coordinates of the turning point from the last part of the question. The next step is to find the x-intercept. And we know that for our x-intercept, the value of y equals to 0. And because we've been able to completely factorize, all I need to do is to equate my x minus 1, x minus 1, so I have that twice. It's going to get the same value. Then 2x plus 3, I'll equate that to 0. So therefore, if x, for the first part, if x minus 1 is equal to 0, then I have x equals to 1 twice. And then for the next one, I have 2x plus 3 equals to 0. So therefore, x equals negative 3 over 2. So with this point, I need to write out my x-intercept. The first one will be x is 1, y is 0. And the next point will be if x is negative 3 over 2, then y will be 0. So using all these various points, I'm going to plug that in my graph as shown. So my graph is not drawn to scale. I'm just going to draw a neat sketch of the graph, starting with my x-intercept. I start with the first one that's sitting at negative 3 over 2 and 0. If I go to find that on the map, that's the first one. That's minus 3 over 2 and 0. And then I have 1 and 0. 1 and 0. Those are my two x-intercept. Then I go to my turning point. My turning point is at negative 2 over 3 and 4/17 over 27. So if I go to negative 2 over 3, it's going to be somewhere here, and 4/17, it's going to have that somewhere here. I'll put a slot in my point, negative 2 over 3 and 4/17 over 27. Then the next turning point is at 1 and 0. Then I need one more point, my y-intercept. The value of x is 0. So I'm going to write that here, and my y-intercept, the value of x equals to 0. So therefore, my y will be 2 times 0 cubed minus 0 squared minus 4 times 0 plus 3. Therefore, the value of y will be positive 3. So the point I'm looking for there will be x is 0 and y is 3. If I go back to the graph, my y-intercept is at 3. So therefore I have x is 0, y is 3. So now that I have all my points, I just need to join them. So with that, I've been able to draw my cubic function of f of x equals 2x cubed minus x squared minus 4x plus 3. The last but not the least part of the question says, for which value of x will f have a point of inflection? To calculate the point of inflection, d squared y over dx squared equals to 0. That is, the second derivative will be equal to 0. Initially, we had f of x equals to x cubed minus x squared minus 4x plus 3. The first derivation will give us 6x squared minus 2x minus 4. So the second one, d squared y over dx squared, will be 12x minus 2, which we are going to equate to 0. And if we solve for x, x will be positive 2 over 12, which is 1 over 6. The question says, for which value of x? So I don't need to find the corresponding y value. So therefore, if x, the value of x will be 1 over 6 at the point of inflection. Thanks for watching. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. Bye.